Hello students, welcome to another session exploring geometry and measures. Today we'll start to understand how parallel lines give us different angle theorems and how we can utilize this information effectively. We'll work through 5 angle theorems and look at some applications of them. First, we'll learn that corresponding angles are always equal. Second, that alternate interior angles are equal. Third, that alternate exterior angles are also equal. Fourth, that co-interior angles sum to 180 degrees. And finally, that co-exterior angles also sum to 180 degrees. So how does this lesson build on what we have learned so far? Well, we've built a solid understanding of some key ideas. First, that parallel lines never meet and run alongside each other forever. Second, that the sum of angles on a straight line always equals 180 degrees. And third, the vertically opposite angle theorem, which shows how opposite angles formed by the intersection of 2 lines are equal. With this strong foundation, we can now dive deeper into the theorems related to parallel lines. We are going to explore several theorems that arise when a transversal intersects parallel lines. A line is transversal when it cuts across 2 or more other lines. We can see this in the diagram on the right, and we will use this diagram to introduce the angle theorems for this lesson. First, we will look at the corresponding angles theorem. This states that when a transversal intersects 2 parallel lines, each pair of corresponding angles are equal. Let's visualize this with our diagram. We'll begin by labeling the parallel lines L and M like this. Notice how they are intersected by a transversal line, which we can label T. Let's go ahead and mark the angles around where lines T and L intersect. We can label them A, B, C, and D. Let's now do the same for the angles where T and M intersect. For these angles, let's label them A', B', C', and D'. The corresponding angles are angles that are on the same side of the transversal and in the same relative position. They always make an F shape, which can be upside down or back to front like this. With this in mind, we can see that A and A' are on the same side of the transversal line T and are in the same relative position. So they are corresponding angles. We can also see the same for the other angle pairs, which are the same color. According to the corresponding angle theorem, each angle pair is equal. That is, angle A equals A', angle B equals B', and so on. While we won't rigorously prove this theorem, we can see that it intuitively makes sense. If angle A in our diagram is not equal to angle A', then the 2 lines L and M would converge, meaning they would eventually touch and therefore not be parallel. This informal reasoning shows that for these lines to be parallel, the angles have to be the same. The main thing to remember, though, is that corresponding angles are always equal. Let's now look at the alternate interior angles theorem. This states that when a transversal intersects 2 parallel lines, the pairs of alternate interior angles are equal. Let's again look at our diagram consisting of parallel lines L and M and the transversal line T. Let's also go ahead and label the angles on the bottom half of line L as A and B like this. And let's also label the angles on the top half of M as C and D. Alternate interior angles are formed on opposite sides of the transversal line and inside the 2 parallel lines. They always form a Z shape, which can be back to front like this. With this in mind, we can see that angles A and D are alternate interior angles, and so are angles B and C. The alternate interior angle theorem tells us that these angle pairs are equal. Let's now prove that this relationship holds. First, let's label the angles on the bottom half of line M, E, and F like this. From the corresponding angles theorem, we know that angle A and angle E are corresponding angles. Therefore, A equals E, which we can write on our diagram. We also know that angle E and angle D are vertically opposite, so angle D equals E. From these two facts, we know A must equal D, which is exactly what the alternate interior angle theorem tells us. We can do the same maneuver to show angle C equals angle B. Try pausing the video and see if you can make this analogous proof. We'll now move on to the alternate exterior angles theorem. This tells us that when a transversal intersects two parallel lines, the pairs of alternate exterior angles are equal. Let's return to our diagram consisting of parallel lines L and M and the transversal line T. This time let's label the angles on the top half of L as A and B. Let's also label the angles on the bottom half of M as C and D. Alternate exterior angles are formed on opposite sides of the transversal line and outside the two parallel lines. With this in mind, we can label the angle pairs AD and BC as alternate exterior angles. The alternate exterior angle theorem tells us these angle pairs are equal, so angle A equals angle D and angle B equals angle C. We can prove this in a similar way to how we proved alternate interior angles. First, let's label the angles beneath A and B as E and F like this. From the fact that vertically opposite angles are equal, we know angle A equals angle F. Additionally, from the fact that angle F and angle D are corresponding angles, we know that they are equal. From these two facts, we know angle A equals angle D, which is what the alternate exterior angle theorem tells us is always the case. Again, pause the video and see if you can construct the analogous proof for why angle B equals angle C. Our next angle theorem is the co-interior angles theorem, which states that when a transversal intersects two parallel lines, each pair of co-interior or same-side interior angles add up to 180 degrees. Let's visualize this again with our trusty parallel lines M and L and transversal line T. Let's go ahead and label angles A and B like this. Co-interior angles lie in between two parallel lines on the same side of the transversal T. They always form a C shape like this. With this in mind, we can label the angle pair AB as being co-interior angles. The co-interior angle theorem tells us that these angles always add up to 180 degrees. We won't present the proof of this theorem here, but you have all the techniques needed to figure it out. Pause the video here and try it out now. Moving on to our final angle theorem, we have the co-exterior angle theorem. This tells us that when a transversal intersects two parallel lines, each pair of co-exterior or same-side exterior angles add up to 180 degrees. Let's again return to our parallel lines L and M and our transversal line T. This time, let's mark the following angles as A and B. The co-exterior angles are exterior angles on the same side of the transversal. With this in mind, we can see that angles A and B are co-exterior. The co-exterior angle theorem tells us that A and B will add up to 180 degrees. The proof of this is straightforward. We can label the following angle C in our diagram. Angle B and C are corresponding angles, so they are equal. Additionally, since angle A and C are on a straight line, they add up to 180 degrees. This means that angle A and B must also add up to 180 degrees. Now that we've introduced these theorems, let's look at how to apply them. First, let's begin with the alternate interior angles theorem. Here's a diagram with two parallel lines L and M cut by a transversal line T. Let's label angles A, B, C, and D like this. In this diagram, we know angle B is 120 degrees. Since lines L and M are parallel, angle C and B are alternate interior angles. We can also see this from the inverse pattern they show. According to the alternate interior angles theorem, these angles are equal, and so C equals 120 degrees too. Let's now see a case of applying the co-interior angle theorem. Here, angle A is 110 degrees. According to the co-interior angles theorem, the sum of the co-interior angles is 180 degrees. Therefore, angle A plus angle B equals 180 degrees. Given angle A is 110 degrees, we can find angle B by solving the equation 110 degrees plus angle B equals 180 degrees. Rearrange this. To find angle B equals 70 degrees. That's it for today's lesson. Let's summarize the techniques we introduced today. We first looked at corresponding angles, noting that these form an F shape and are always equal. We then turned to alternate interior angles, which form a Z shape and are always equal. Thirdly, we learned that alternate exterior angles are always equal. We then studied co-interior angles and learned these form a C shape and always add up to 180 degrees. Finally, we looked at co-exterior angles, which always add up to 180 degrees. Throughout the lesson, we used diagrams to visualize these theorems and understand how they apply to different geometric problems. By recognizing and applying these angle theorems, we can determine unknown angle measures and prove lines are parallel, enhancing our problem-solving skills in geometry. This knowledge is crucial for tackling more complex geometrical problems and will serve as a solid foundation for future lessons on space and measures in geometry.